Hi there, Gus, back again. Today there's two things I want to talk about. Firstly, I want to give you a set of guidelines or rules for teaching, which I keep in mind myself. As well as teaching maths for a long time, I've taught other people about the processes of teaching maths. And that's caused me to read quite a bit and think and to explore. And as a result of that, I've come up with these guidelines. And I'd like to share those with you. Here's an interesting little book, How to Solve It, by a mathematician, George Polya. It's written for a higher level of mathematics than we're talking about here, but it's got a very interesting idea that applies at any level. I'll tell you. Polya's rules of teaching. The first rule of teaching is to know what you are supposed to teach. The second rule of teaching is to know a little more than what you are supposed to teach. Now, I roll those two into one for my first rule of teaching. In order to teach, you've got to have some subject knowledge, and you've got to have it in a little more depth than the thing you're teaching today. You need to see it as part of a bigger picture. So that's the first rule, subject knowledge. Secondly, knowing your stuff is essential, but it's not enough. If you're going to get that across to other people, you have to think about the process by which you do that and prepare it. Thirdly, if you're going to talk to people, you're going to use words, and some of these are going to be technical. You will need to explain, make sure that your listeners understand the same thing as you understand by the words that you use. That was what I was doing in the first episode, where I sorted out what the term digits and numbers meant. And finally, we take in information through our senses. I'm talking at the moment and you're hearing what I'm saying. I put images on the board and you see those. Thirdly, we can use our hands and our bodies to touch things and to move. Technically, this is called tactile kinesthetic. And one of my rules is always to look for an activity or a piece of equipment that you can use to get ideas across. This is much more effective than just talking and just writing. So then, there are my four guidelines or rules of teaching. Know your stuff, plan your lesson, explain the terms that you're going to use, and look for an activity. That's the first thing. The second thing I want to do is to put that first rule into effect. We've talked about the digits and how to get these across to children. The names, to recognise them and know their order. Now I want to look at the uses that we make of these digits in everyday life. Some of those uses are to do with mathematics, numerical uses. That's what they were designed for. But we also use them in non-mathematical ways to convey ideas that are not in fact numerical. And there are basically two of these. We use them to make labels to identify things. On your car, there's a license plate that says ABC 345. Tells which car we're talking about. On your letterbox, 221B identifies the house. On a sports player's shirt, 42 says which player are we talking about. On the spine of a book, 510.245 tells you which book we're talking about and where to find it on the library shelf. These uses then are to make labels, often in conjunction with other symbols like the letters. And then we also put them on keys on certain implements that we use, like a telephone or a keypad on an ATM. And we remember a sequence of actions of pushing those buttons by keeping in mind the number sequence. 1732 tells you which buttons to push. They're not really numbers, although we call them phone numbers and PIN numbers. They're not really numbers because if you try to combine two of them by adding them, you don't get any meaningful result. They're better called perhaps codes, a phone code or a PIN code, but convention has us calling them numbers. Those then are the principal non-numerical uses that we make of our digits. Then there are the numerical ones. And there are three principal numerical uses of our digits. Firstly, we use them to talk about quantity. And there are two types of quantity. To begin with, we've got to look at the idea of a group of separate objects and being able to describe how many objects there are in that group. Mathematicians call this cardinal number. The word cardinal comes from a Latin word, cardinalis, which means hinge, because everything hinges upon this use of number. You may know the cardinal points of the compass, north, south, east and west, and then we subdivide from there. Now, this use of number is the number that I was talking about before that Peano was describing. It starts at 0 and it goes in jumps. It's talking about a bunch of separate, discrete objects is the mathematical term for it. That's with an E-T-E. Discrete with an E-E-T means about discretion, you know, keeping your mouth shut. So that is the first and foremost use of our digits. The use for which they were created. To be able to answer the question, how many objects are there in a group? An idea which starts at 0 and goes in jumps. Now some things that we describe in life are not like that at all. They go in a flowing, continuous way. We describe these numbers in everyday terms as measurements. For example, how long is that? Or how much of this have we got? Or how long has that been going on? Those three basic ideas, length, mass and time, are the ingredients which can be used to make up other measurements as well, like how fast did that go by? Or how much water is in that glass? Mathematicians have a name for these too. They call them real numbers, which is a funny sounding term to people ordinarily, but there are numbers other than the ones that we're going to look at here. Mathematicians have a set of numbers they call complex or imaginary numbers. So these real numbers describe quantities which move in a continuous way, and where we're answering the question, how much of that have you got, rather than how many. So we have these two ideas, a group of distinct separate objects where the question is how many are there, and the answer starts at 0 and goes in jumps, and the question how much of this have we got, where we measure something. And the answer again starts at 0, but it moves in a continuous and flowing way. Now clearly, this idea is a more advanced idea than this one, because to answer that question we have to take our line, either literally length or representing some other quantity, and we have to put steps along it. And that is a process that comes from here. How many steps have you gone down the line? And then we have to find a way of describing how about going in between those steps. So this is the more basic idea, and this is the more advanced idea which follows on from that. And the third use we're going to put these to goes back to a group of separate objects again. And as well as saying how many of those objects there are, often we will put them into a sequence and say whereabouts each one came in that sequence. A position in the sequence. This is called ordinal number. From the same word as order, because that's what we're doing. Now this one starts at 1, or more precisely at first, because it goes first, second, third, etc. Although we often just say 1, 2 and 3 for position. So there are our 3 uses in everyday life that we are going to put these digits to, which are of a mathematical or numerical idea. Now there's no question about where it all starts. It begins with a group of separate objects. And the 2 things that we are going to get across to children are the idea of how many things are there in that group, the cardinal number, which is a counting process and which starts at 0, and the associated idea of whereabouts did that each object come in that sequence, which is an individual thing rather than a collective thing, and it starts at 1, or more precisely at first. But there is no question that these ideas are the place where we have to start. We even have a section of our brain dedicated to understanding those ideas. The numerosity module, neuropsychologists call it. And when I come back, we're going to get started on that process. Ka kite.